Hello everyone, this is the solution for problem 2 in homework 2. So, in this problem, x, the random variable x, satisfies uniform distribution over the interval a, b, and y is equal to the square of x. So firstly, we want to have the density function and the probability density function and the conditional density function of random variable x. So for the uniform distribution, it is the probability density function is a constant. So actually you need to satisfy the CDF is smaller than 1 and equal to 1 when x tends to infinity. So it is easy to know that the probability density is b minus 1 over b minus a when x is larger than a and smaller than b, when x is in the interval. If x is not in the interval, it is equals to 0. So it is the probability density function. Now we want to have the conditional density function. So it is equal to the interval from infinity to x over the PDF. So when x is smaller than a, so it is definitely equals 0 because the probability density is always 0. So if x is larger than a and smaller than b, so this should be the interval from of infinity. So it is interval from a to x over b minus a dx. So du. So it is b minus a times x minus a. So if x larger than b, it is always 1. So now we get the probability density function and the conditional density function, and we want to draw the sketch. So for assume this is the interval a from a to b. So this is the value of b minus a over 1. So the PDF is a constant over this part. So otherwise it equals 0. So for the CDF, this is the interval of from a to b, and this is the value of 1. So it should be, at first it is always 0, then it increases to 1 linearly in the interval, then it remains 1 afterwards. So this is the CDF. So now if we know the value of a and the b, we want to get the PDF and the CDF of variable y. So how to get that? Firstly, I want to get the CDF, then I compute the gradient of the CDF. I can get the PDF. So for the CDF, from the definition is the probability of random variable. So sorry, this is y over y. The probability of random variable y is smaller than y. So because y is equal to the square of x, so this is the square of x is smaller than y. So firstly, when y is smaller than 0, then the square of x is always larger than y. So at this time it is equal to 0. So if y is larger than 0, so it is equal to x larger than the square of minus the square root of the negative square root of y smaller than the square root of y. So it should be 0 when y smaller than 0, when y larger than 0. It should be the CDF of square root of y minus the CDF of negative the square root of y. So firstly, if y is larger than 0 and smaller than y, at this time it is equal to, so it is equal to fx square root y minus fx minus square root y. So at this time the square root of y is smaller than 1 and larger than 0, and minus square root of y is smaller than 0, larger than minus 1. So these two variables, the value of square root and negative square root, is in the interval -1, 2, 3. So the probability, the CDF should be b minus a over square root of y minus b minus a negative square root of y. So it should be b minus a 2 times square root of y. b minus a is 3 minus negative 1 times 2 square root of y. So it is 2 the half of the square root of y. So this is the CDF in this interval. So when y is larger than 1 and smaller than 9. So at this time the square root of y is larger than 1 and smaller than 3, and the negative square root is smaller than -1 and larger than negative 3. So this is in the interval AB. So this is not, and it is in the and this is in the interval -infinity to -1. So at this time the CDF is 4 over square root of y minus plus oh, sorry for that. So it should be from -1 to square root of y, the probability density function of y. So it should be -1 square root of y 4 over 1 dy. So it should be square root of y plus 1 over 4. So at last, if y is larger than 9, the density function is always 1. The CDF is always 1. So in conclusion, the CDF of variable y is 0 when y smaller than 0, is a half of a square root of y if y larger than 0 and smaller than 1 is square root of y plus 1 over 4 if y larger than y and 1 and smaller than 9. So it is 1 when y larger than 9. So then we want to get the PDF. The PDF is the gradient of the CDF. So it is also can be written as it is 0 when y is smaller than 0. The gradient of this function is, so this is 4 square root of y over 1, so y larger than 0, so it is not equal, larger than 0 and smaller than y, so this is 1 over 8 times square root of y if y larger than 1 and smaller than 9. So the gradient of a constant is 0, so it is 0 when y larger than 0. So then we want to draw the stretch of CDM and the PDF. So for the density function, so this is a plot of the density function. So 1, 9, and this is 1 over 8, and this is 1 over 4. So firstly, when y is smaller than 0, it always 0. Then if when in this interval, it should be, the plot should look like this. So when y in this interval, the plot should look like this. So then it drops to 0 when y increases to 9. So this is the PDF. So for the CDF, this is 1 and this is 9. So assume this is, assume this is 1 over 2 and this is 1. So firstly, when y is smaller than 0, it is always 0. So then it increased to 1 over 2 when y equals 1. Then it increased to 1 when y equals 9. So then it keeps 1 when y larger than 1. So this is the CDF. Now we successfully solve this problem. At last, we want to get the expected value of variable y. So it should be from infinity to positive infinity. So it should be negative to positive. So it should be from 0 to 1 y times the density function dy plus 1 to 9. So it should be 0, 1, 1 over 4. So this is the square root of y dy plus 1 over 8, 1 to 9, the square root of y dy. So it should be 1 over 4 1 to 0 plus 1 over 8 3 over 2 from 1 to 0. So this is 4 times 2 over 3 plus 1 over 8 times. Also this is 9 and this is 1. So this is 9 2 over 3 3 over 2 equals 2 times 3 cubic of 3. Yes, so it should be 2 times 9. It should be 18 minus 2 over 3. Yes, so it should be 1 over 6 plus minus so it should be, the denominator is 12 and this part is 2 plus 27 minus 1, so it's 28. So it should be so this is the expectation. So now we solve this problem.